A circular redwood hot tub, excuse me, has a diameter of 5.03 feet, allowing 4 inches extra for a fastening. What length of steel band is needed to encircle the tub and hold its boards in place? Um, so the first thing when I'm reading through this, well, you can think about the situation. We have a circular hot tub, and we're going to have a band. These redwood planks are held in, kind of like how a barrel is done. We have the individual planks here, and the thing that holds them, the only thing that really holds them in place is the tension from this steel band that goes around the hot tub. This band right here. And we're trying to figure out how long that band should be, and it looks like there should be, it says 4 inches of overlap. So the first thing I notice when I'm looking at this is that we have one measurement in feet and another measurement in inches, and I don't like having these measurements in different units because it's going to cause issues most likely. Now I could convert them both to feet or both to inches. I'm a fan of going for both the smaller units. Well, let's see what it looks like. 5.03 times 12 gives us 60.36 rather. So this I'm going to call 60.36. Now this number has 3 significant digits, and when I round this at the very end of the problem, I'm going to be rounding back to 3 significant digits most likely. But at least for the moment, I'm going to go ahead and leave it as 4. Yeah, that's the entire thing that was displayed in this number. So let's see. We have a diameter of 5.03 feet. From here to here is 5.03 feet, or 60.36 inches. Yeah, let me not go back and forth. 60.36. So the distance from here to here is 60.36. I'm looking for the distance around the outside of the tub, which is generally described as the circumference. And the circumference formula is 2 pi r. Now this number right here is my diameter. Now what I need to do is I need to figure out what my radius is. And in general, the diameter is twice the radius. If I know the diameter is 60.36, equal to twice the radius, if I was to divide both sides by 2, let me move this. If I was to divide both sides by 2, I get 30.18 equals r. So my radius is 30.18 inches. And thus I can get my circumference to be 2 times pi times r, which is, this r is the 30.18. So I'll type that into my calculator. 2 times pi times 30.18, which gives me 189.62 whatever. Equals approximately 189.62 stuff. 626. All right. Actually, yeah. I was hoping to not have to round up or down, or hoping to not have to round up, but whatever. 627 if I actually round it to the nearest. I'm actually just going to use the value that's stored in the calculator instead of the one I wrote down here, because the one that's stored in the calculator right here has more digits of accuracy, thus less error. All right, so this is the circumference of the tub, and we're trying to allow 4 inches of extra steel band. So this is the distance around the outside of the tub. This is, as I said, if we were to go from here and straight back, but it doesn't have any overlap. So to get that overlap, I want 4 inches extra. I'm just going to add 4 to it. That's 193.62, and it looks like this says it should be rounded, or, it makes the most sense here. This is to 3 significant digits. I'm going to round this to 3 significant digits. Yeah, I don't know. There's different. I suppose you could call it 193.5 inches, 193 and 3/4, or 193 and 5/8 is actually pretty close. I'm going to go ahead and just call it. Add 4 inches. We're going to go ahead and call this 194 inches. The steel band going around this hot tub, I would want it to be 194 inches long. I'm ignoring the thickness of this steel band. I know when we're in this next video we're going to be talking about the thickness of a pipe, and we mess around with the radius of the curvature because of the thickness of the pipe. I'm ignoring that in this particular problem. So it's not that thick of a band to the point where it would matter. And I'm rounding up enough, so I think that 4 inches, this actually ends up going up by 4.4 inches. That would probably be fine.